And we see that graphite rod is near the edge of the magnet, and magnet has some curvature on the surface. Here is a finished device in an iron block, milled 20 millimeter deep slit and 5.5 millimeter wide. Magnets are 2 millimeter wide, and pencil rod 0.7 millimeters. Gap is 1.5 millimeters. Now trapping a speck of graphite from spectroscopy rod. The magnets are not glued. They can be moved around with some wooden stick, and they were inserted using aluminum spacer to prevent them from sticking together. Now we have levitating a very tiny speck. I want to put this graphite speck in a chamber with ultrasonic mist and see if a big drop would grow around the graphite. Here is a top view. It is possible to move the trap around without losing particle, but it does not like knocking on the table. The iron piece is 1 inch. Shining laser light onto it has no effect. It's 20 milliwatts laser pointer. In optical tweezers would not be possible to levitate such large object, but here it is possible because magnetic force acts on the whole volume of the graphite. But we are limited to graphite, bismuth, but silica and liquid is already hard. On the hard disk drive magnet with slightly curved end sides, and cut it in half with grinder and broke it. And the poles are north and south, attracting each other. A metal vise to adjust the distance and also to loop magnetic fields. Slightly glued to the metal, 0.7 millimeter paper spacer in between them, spectroscopic graphite speck. Next I am increasing the gap size. These specks have slightly different magnetic properties. Some levitate better than others. Gap distance about 1 millimeter. Hard disk magnets with attracting poles, north and south pole. And here is just paper spacer to prevent magnets from sticking together. Can be also non-magnetic aluminum spacer. We have levitating particle and I'm increasing the gap. More than 1.5 millimeters. Magnet thickness is 2 millimeters and curved face length 14 millimeters. 1 millimeter aluminum gap and no levitation at all. There is no magnetic circuit which closes the poles. Very, very weak. So this is huge difference. Assembled magnetic field circuit. Well, the force is strong. Everything is held together. Even with a single magnetic slab, I cannot pull the magnets away from each other. But if they are not touching magnet wire iron, then I can easily move them away. With a single magnet it does not stick, but now it sticks, because there is another iron piece on another side. But with such single magnet cannot levitate. Amazing. The force of magnets has become so large that 1.5 millimeter gap is too little. Small speck levitates very well. And this is a side view showing the height. 3 millimeter gap was too much. Everything falls through. Magnets are only 2 millimeters wide. 2 millimeters gap is too much. Things fall through. 1 millimeter gap, graphite rod is pushed out. 1 millimeter gap, aluminum plate. See the first evidence that glass levitates. I can push it down and it comes up. Repeated try shows no levitation of glass, unfortunately. Rod diameter is 0.5 millimeters and the spacing is 0.7 millimeters. Dust mist through a small hole on the back. Today got it working with tiny water droplets. Magnets north and south in front of each other, and spacing is 2 sheets of paper. Got it working. Gap between 2 magnets, strong ones, north and south pole are in the gap, and they are separated by 2 sheets of paper. And these magnets are sticking to magnetic waveguide, magnetic field guide.